pretty amazing when you think about it, right? All the automation involved in flying these days. I mean,
Hmm.
it's not some sci-fi movie. It's happening right now up in the air every single day.
Absolutely. And it really is involved in practically every stage of flight,
Yeah.
from when they first fire up those engines to the second the wheels touch down on the runway.
Yeah, it's everywhere. And that's exactly what we're going to try to unpack today. We've got this really interesting chapter here all about automation and how it's used to manage the flight path of an aircraft.
Right.
And in this deep dive, we're going to kind of go through it all, try to make sense of how these systems actually work up there at 30,000 feet.
Yeah.
And maybe even more importantly, what we all need to be aware of, especially as this technology keeps advancing and becoming even more prevalent.
Yeah, for sure.
So we're talking about a lot of different systems here. Um, obviously, we've got the flight management systems, or FMS, working alongside the autopilot. But we're also looking at things like automated fuel management, digital engine controls, and of course, all those sophisticated avionics that handle loading those incredibly detailed flight plans.
Yep. All kinds of cool stuff.
Okay, so let's start with the basics, right? What's the main goal, the big idea behind all this automation in the cockpit?
Well, at its core, you can really think of automation as like a constant helper for the pilots. The big goal is to lessen their workload, both mentally and physically. Flying, especially during certain phases of flight, can be hugely demanding. So automation steps in to kind of take over some of those more routine tasks. And in a sense, it's like having a powerful cognitive amplifier in the cockpit.
Oh, interesting.
Yeah, if it's working well, it helps the pilots focus on the bigger picture, the strategic decisions. But just like any amplifier, you got to be careful. If you're not feeding it the right information or keeping a close eye on what it's doing, things can go wrong pretty quickly.
Right, right. So it's kind of like it's freeing up their mental bandwidth so they can focus on other stuff.
Exactly. And by taking over some of those more repetitive or less critical tasks, automation can potentially lead to something we call situational awareness.
Okay.
Instead of constantly fiddling with controls, pilots can now direct their attention to getting a much broader understanding of where their aircraft is, where it's going, and what's happening around them.
So instead of just being focused on like the mechanics of flying at that moment, they can kind of zoom out, see the big picture, like traffic, weather patterns, all that.
Exactly, and allows them to concentrate more on the overall flight path. Making strategic decisions, anticipating potential problems, and just generally managing the entire flight in a more effective way.
It's pretty remarkable when you think about how far this has come. The chapter mentioned that automation started in some pretty basic ways.
Oh yeah, it's been a gradual evolution for sure.
Yeah.
One good example from the chapter is electric flaps. Think back to the old days. A pilot would have to hold a switch, watch an indicator, and carefully adjust the flaps to the position they wanted. Then came a small but important step toward automation. They added these little detents to the switch.
Okay.
So with a simple click, the flaps would automatically move to a preset position. It was like the first version of cruise control, but for your flaps.
Love that analogy.
Right. Small change, but it saved the pilot time and attention, which is always a good thing in the cockpit.
For sure. And so from those individual automated systems, we've moved on to these hugely complex integrated computer-based systems.
Mm.
And it's not just the big airliners anymore. It's filtering down to smaller general aviation aircraft too.
Right. That's the big shift.
Yeah.
Computers and digital technology really changed the game. Now you can control a whole bunch of functions simultaneously, and that led to the sophisticated flight management systems we're talking about today.
Okay, so we've got the why, the intended benefits. But let's not shy away from the downsides, right? The chapter has some pretty serious cautions about becoming too reliant on automation.
Yeah, there are definitely some potential pitfalls. We got to be realistic about that. It's not a magic bullet.
No.
So even though it's designed to help, automation can, ironically, sometimes actually increase workload, create confusion, and even lead to errors.
That's kind of counterintuitive.
It is, but it's important to remember. It's not a perfect solution, and using it effectively really requires a skilled and thoughtful approach from the pilots.
So one of the big concerns mentioned is complacency. What exactly does that look like in the context of aviation?
Sure, so when pilots get used to the automation handling a lot of the flying, there's a risk they might become, well, less involved, less vigilant, less in tune with the subtle cues or changes in how the plane's behaving. They just get so used to the automation working perfectly that they might not notice those little signs that something's not quite right.
It's Kind of like when you drive an automatic car all the time, then you try to drive a manual and you're suddenly fumbling around. Is it that kind of skill degradation?
You got it. And the chapter specifically mentions the potential for degraded manual flying skills.
Uh-huh.
If pilots rely too heavily on the autopilot, their ability to take over and fly the plane manually can diminish. It's like a muscle that gets weak if you don't use it.
Makes sense. Use it or lose it.
All right. And the chapter brings up this really vivid example about icing conditions, which I think really drives that point home.
Yeah. Yeah. Tell me about that.
Okay, so imagine this. You've got this automated system, and it's making tiny adjustments to compensate for ice building up on the wings and tail surfaces.
Okay.
And it's doing a great job right up until it hits its limit.
Right.
Now, if the autopilot suddenly disengages at that point, a pilot who hasn't flown manually in a while could be caught completely unprepared to deal with an aircraft that's suddenly acting very differently than they're used to.
That's a scary thought. And it's not just sudden malfunctions like that, right? The chapter also talked about how needing to reprogram the automation unexpectedly can cause problems.
Yeah, that's another big one. So a pilot might be really good at the normal operation of the automation, but when they suddenly have to reprogram the FMS, like if they get new instructions from air traffic control or have to deviate from the planned route, things can get tricky.
Mm-hmm.
That increased workload and the possibility of making a mistake when entering the new data can mean the aircraft doesn't quite follow the intended path, which can obviously have some pretty undesirable consequences.
So it's almost like the automation is so good at the routine stuff that when something out of the ordinary pops up, it can actually make things harder if you're not totally on top of it.
Precisely. That's why the chapter is so big on pilots being ready and able to fly manually and maintain the desired flight path, even when they're normally using the automation. You got to be ready to step in at any moment.
So this brings us to the idea of finding the right balance between automated and manual flight, right? It sounds like it's not an either situation.
Definitely not. It's about finding that sweet spot. Pilots have the authority to choose how much automation they use, and good risk management suggests that automation should be seen as a tool to help them, not to cover up any lack of basic flying skills.
Right. So it's finding that middle ground where you're taking advantage of the technology, but not becoming overly reliant on it.
Exactly, and that ideal balance takes into account both the current workload and the pilot's skill level. It's all about giving the pilot the best possible chance to monitor the flight path and the overall condition of the aircraft. And the chapter points out a really common mistake: failing to reduce the level of automation when the situation changes.
That's interesting. It's not just knowing when to turn it on, but also when to dial it back or even turn it off
Yeah,
completely. The
exactly.
chapter uses this great example of flying an approach, which I thought really illustrated this point well.
Yeah, it's a really good example of how dynamic things can be up there. So initially, a pilot might be flying the approach manually, no problem.
Okay.
But then all these other tasks start piling up: getting the latest weather info, loading the approach procedure into the FMS, running through checklists, and suddenly the workload spikes.
Wow. Yeah.
And that's the perfect time to engage the autopilot to track the approach course. It frees up the pilot's mental capacity to handle those other crucial tasks efficiently.
So the autopilot steps in to manage that surge in workload during that busy phase of flight.
Exactly. But then things change again.
Oh,
They're just about to start the approach, and air traffic control comes on and says, "Nope, we're changing your plan. We need you to enter a holding pattern over here."
oh, wow. Okay.
So now all that complex automation that was set up for the approach is no longer relevant. And this is where, according to the chapter, it's best to switch to a simpler autopilot mode, one that just maintains a specific heading and altitude. That way, the pilot can easily comply with the new ATC instructions and also have the mental bandwidth to reprogram the FMS for the holding pattern and reconfigure the plane as needed.
Gotcha. So it's about using the right amount of automation for this specific situation and being flexible enough to adjust as things change.
Exactly. And the chapter even mentions that pilots might intentionally fly manually sometimes, even if they don't have to,
Oh, why is that?
just to keep their skills sharp. Even on a routine flight, a pilot might decide to disengage the autopilot for a bit, just to practice flying the plane by hand.
Okay.
It helps them stay comfortable and capable of taking over smoothly if the automation fails or if something unexpected happens.
That's smart. Okay, so we've talked about the pros, the cons, the balance. Now, how about the actual interaction with all this automation? The chapter lays out a 3-step process.
Yeah, it's a really fundamental framework: anticipate, act, and verify.
Catchy.
Yeah, and it's a continuous loop, Every time a pilot uses an automated system, they should be going through these 3 steps.
Okay, break it down for me. What does anticipate mean in this context?
Well, anticipate means really understanding the automation well enough to predict how it's going to behave before you do anything, before you make any changes or enter any inputs.
Got it.
It means knowing the system's logic, its different modes, and how it'll probably react to various commands or changes in the environment. It's like a chess player thinking a few moves ahead, trying to anticipate their opponent's response. You got to think, if I do this, what will the system do?
So it's not just about pushing buttons. It's about understanding what might happen after you push those buttons.
Exactly. Then comes the act part, which is pretty straightforward.
Right.
It's the physical execution, pressing the buttons, turning the knobs, entering the data into the FMS, and it's got to be done carefully and precisely.
Makes sense. And finally, the verify step. I imagine this is pretty crucial.
Oh, it's absolutely vital. This is where the pilot checks that the plane or the avionics did what they were supposed to do. They check the flight mode annunciator on the primary flight display. That's the screen that tells them what the autopilot's doing. They monitor the flight path, and they just make sure everything's working as intended.
I see. The chapter has this helpful example using the flight mode annunciator. Can you explain that a bit more?
Sure. So imagine you see LOC, HDG, APLT 9000 FTGS on the display.
Okay, lots of abbreviations there.
Right, but they tell you exactly what the autopilot's doing. HDG means it's holding the current heading, ALT maintains the selected altitude, and LOC and GS are armed to capture the lateral and vertical guidance of the approach.
Right.
Now, a pilot who doesn't fully understand the system might not realize what could happen if, say, the navigation source for the autopilot was interrupted somehow. The system might revert to a more basic mode, like just holding the wings level, and the pilot could be caught off guard if they weren't expecting that change.
So if they weren't paying close attention to that enunciator or didn't know what those abbreviations meant, they could easily lose track of where they're supposed to be going.
Precisely. And that takes us right to the potential consequences of not following this anticipate, act, verify process.
Which are?
Well, complacency and a loss of situational awareness are 2 big dangers. If pilots become too passive, they're not really in control anymore.
Right.
And then if something unexpected happens, like a change in the flight plan or a system malfunction, the workload and confusion can go through the roof.
Yeah, I could see how that would be a recipe for disaster.
Exactly. And the chapter talks about a really tragic, real-world example, the 1995 accident in Colombia.
Oh, right. I remember reading about that.
It's a stark reminder of what can go wrong. The flight crew was cleared for an approach unexpectedly and got disoriented and confused while using the FMS for navigation. They didn't switch back to basic radio navigation, and the FMS guidance was confusing and created a huge workload at a very critical point in the flight. And tragically, the plane ended up flying into a mountain.
That's awful.
Yeah.
And it wasn't just a navigation issue, was it? There was something else.
You're right. They also, in all the confusion, forgot to retract the speed brakes after they added full power to try and climb away from the mountain.
Oh, wow.
And that extra drag from the speed brakes prevented them from climbing fast enough to clear the terrain. It just goes to show how one little slick-up can snowball into something truly catastrophic.
That's a powerful example of how important it is to stay ahead of the automation, to be mentally prepared for things to go off script. So, how do we use automation well? What are the key principles for making it a benefit and not a hazard?
Well, the chapter really emphasizes that automation can be a huge help for managing risk, especially when there's a high workload, like in single pilot operations.
Okay.
But it's super important to remember that not knowing how to use the automation properly can be a risk in itself.
So you can't just assume that having fancy technology automatically makes things safer.
Exactly. You need the training and the proficiency to use it effectively.
Right. And we keep coming back to this idea of maintaining strong manual flying skills.
Yes, automation should complement those skills, not replace them.
Makes sense.
The chapter recommends that pilots get lots of training and practice with automation under VFR conditions, with a qualified instructor, before they try using it in IFR, where things can get a lot more challenging.
So start simple, build that foundation before jumping into the deep end. And the chapter also mentioned flight simulators.
Right, yeah. Simulators are incredibly valuable. They let you practice these procedures in a safe environment, even under high workload conditions.
Right.
You can run through all kinds of scenarios, like system failures or changes to the flight plan, and you can learn from your mistakes without any real-world consequences.
It's like a dress rehearsal for pilots.
Exactly. And finally, the chapter really stresses the importance of understanding the limitations of these automated systems, knowing any operating restrictions, and being familiar with emergency procedures like how to disengage the autopilot quickly if you need to.
So it's not enough to just know how to program the system. You got to understand the nuts and bolts, the potential pitfalls.
Precisely. That deep understanding is what allows you to anticipate, act, and verify effectively.
Okay, we've covered a lot of ground here. Let's recap some of the key takeaways.
Okay, so first off, it's clear that automated systems like autopilots and FMS are incredibly helpful tools. They make managing the flight path much easier.
But just because the autopilot's on doesn't mean the pilot can check out, right?
No way.
Uh,
Maintaining that situational awareness has got to be the #1 priority, always.
And again, we can't overemphasize the importance of balancing the use of automation with those core manual flying skills. Pilots have to be ready to take over at any moment.
For sure.
So bottom line, when it's used correctly, automation can significantly reduce risk and help prevent accidents.
Exactly. It's all about being a knowledgeable, skilled, and alert user of this technology.
This has been a really eye-opening look at automation in modern aviation. It's amazing to see what it can do, but also to understand the potential risks.
It is fascinating, and it really highlights that even with all this advanced technology, you still need a well-trained, knowledgeable, and engaged human in the loop.
Absolutely. So as we wrap up, here's a final thought for you, our listeners.
Okay?
As we see more and more automation in so many areas of life, not just aviation, think cars, workplaces, even our homes, how do we ensure that our increasing reliance on these systems actually makes us more capable and aware, not less?
Right.
It's easy to become complacent and let those essential skills and understanding fade away. It's definitely something to think about as we move further into this world of automation.
It's a really important question, and we encourage you to consider these principles whenever you interact with automation, no matter where it is in your life.
Thanks for joining us for this deep dive. We hope you found it informative. Until next time.
See you then.
Bye.